everyone. Today I want to introduce introduction to visualization by using the Python programming language. In this workshop we will learn how to use Python bindings such as NumPy, Pandas, Matplotlib or Seaborn for visualization and data analytics. First, make sure you go to our website sites.google.com, g.clemson.edu with home. You will find a lot of information about visualization, particularly about this workshop with Python or other workshops that we had in the past, like Microsoft Power BI or D3JS by using the JavaScript. So in the home page, you would find all the workshops that we had, the materials here, and the recent workshop I will talk about today in this video is the introduction to data visualization with Python. So if you click here, you would find some information about the outline and what's needed for getting started in this workshop. So first, make sure that if you go through all the materials in this workshop, send your visualization that created based on this workshop by using the Python to my email address shown here as yousefi@clemson.edu by Friday, July 31st to receive a certificate of completion of this workshop. So the outline here is to just give you a basic introduction to data analytics and visualization by using Python, and then I will introduce some information about Matplotlib and Seaborn, which are the main data visualization libraries or Python bindings available in the Python environment. Then we will move on to create some basic bar charts and box plots by using the NumPy, Pandas, or Matplotlib. Then we will learn how to use a little bit more advanced visualization package called Seaborn, which makes all the visualization tasks much more easier in comparison to the traditional using the Matplotlib library. Then we will learn how to create a scatter plots, line charts, and 2D heat maps, which is useful for visualization of the multidimensional data sets. And finally, we will learn how to create animation based on our visualization to show the dynamics and time dependency of the data. The only prerequisite we have for this workshop is to create a Google account. You could use your Clemson University Google account for signing in the Google Colab, which gives you a free Python environment as a notebook that you can just run all the commands, see the visualization, save the notebook, or even share with your collaborators or among other researchers. And finally, I'm Mehrdad Yousefi. As a data visualization engineer, you can just contact me by my email address shown here as yousefi@clemson.edu if you have any question or if you want to request any specific information or materials for any specific data visualization library or software. So thank you for watching us. So we will moving to the first section of introduction to data analytics and visualization with Python. If you click on the next page, as is written here, Python is a really powerful high-level programming language that is designed to be similar to the English language, and it's more understandable for the beginners in comparison to the C and C++ or Fortran languages for sure. And because of this simplicity and a lot of powerful tools that is available in the Python, it's really useful for rapid prototyping or creating some softwares that could be run and tested really easily and fast. So based on these powerful tools, of course, we have a lot of useful tools and information about how to use Python for the data analytics and visualization, particularly in the engineering, computer science, or even human-related subject studies. Actually, the basic concept of the visualization in Python, or even you can just generalize it to any other softwares that could be used for the data analytics and visualization, is to maintain and organize the data set in terms of the numeric tables or arrays or variables that we have, and then use this data set organized well in your software or programming language, particularly for the Python, as arrays or variables, to create charts, plots, or other visualization that could just convey an important message for your user, to show maybe a hidden relation between some variables or parameters that could give you some insight about trends or some hidden information in your data set. One of the advantage of the Python is that you can just use it for any visualization in terms of the data analytics or even scientific visualization. And also, it just gives you a reproducible and shareable environment as called Jupyter Notebook. And because sometimes installing all the dependencies of the Python bindings, for example, NumPy, Pandas, Seaborn, or Matplotlib, maybe is time consuming or even maybe difficult for the beginners. So we used a recently launched Python environment by Google called the Google Colab, which just gives you a free Python environment that you could just test your code, see the result, and even share it with other researchers. So that's really useful because you don't need to use your own computer. It just gives you a computer in the Google servers with some specified configuration. Even it just could give you some access to the GPUs, and then you can just build your code and test it and see the results. So in this section, we will see how to initialize the Python environment by using the Google Colab. In order to use the Python environment available in the Google Colab, you need to use your Clemson University Google account. Make sure you just use your email address ending with the g.clemson.edu, or even you could just use any other personal Google account that you created for the Gmail or any other Google account that you have. So first we need to go to this website here. Go to Google Colab website, Google colabresearch.google.com. Because I'm just signed in, I'm just signed out here to show you how you can just sign in here. Okay, if you go to the Google Colab website as for the first time, you would see that you need to sign in here. But that's the main page of the Google Colab. If you click on the sign in, it just asks you which Google account that you want to use for this Python environment. I'm just want to use my g.clemson.edu email address, so I'm just click here. Or even if I want to use any other Google account, I would type my email address here and then click next. Then you need to type your password, of course. Click next. And then if successfully you signed in the Google Colab environment, you should see this page. It just gives you some recent pages that you opened, or if you have Google Drive or GitHub account connected to this Google Colab environment. But as a beginner, you might just see the new notebook here. So if you click on the new notebook, it would just create a new notebook for you. So that's the first initialized Python environment in the Google Colab website if you just signed in successfully. So make sure after the successful sign in, you could see this environment here as a blank environment or blank Jupyter Notebook or notebook here. So I will go briefly over the details that we saw here. Go to the website of Google, colabresearch.google.com. Then, as I said, click on the sign in. Then use your g.clemson.edu account. Just put your email address here and then click on this next. Then after successful login, you should see this page here. And then in order to create a new notebook, just click on the new notebook. It just initialize a blank notebook for you. And finally, if you sign in successfully, you should see this blank notebook or blank Python environment. So that's the sign that you were successful to sign in the Google Colab environment. And in the next section, we'll learn how to bring all the packages that we need for the visualization and organizing the data, such as the NumPy, Pandas, Matplotlib, and Seaborn. At the end, you need to download 2 different data sets that will be used for the visualization in this workshop. The first one is the South Carolina COVID-19 data set at the county level for April 20, 2020, extracted from the New York Times data set. You can just click here and download this data set. And the other one is the breast cancer data set from the Milwaukee, Wisconsin-Milwaukee University, and then you can just click here to download this data set. These are the 2 files that we need for visualization in this workshop. So make sure you just download these 2 files before starting the going through the materials. So I'm just going to close the blank notebook, and in the next videos we will learn how to initialize the Python modules and create the visualization. Thank you so much. That's the second part of the introduction to data analytics and visualization by using Python. Here in the first section, we will learn how to initialize the Python environment in the Google Colab research account. Now we will move on to the next section to initializing the Python modules and see how we could use them for the visualization. So if you click on the next page, so that's the introduction to the NumPy, Pandas, Matplotlib, and Seaborn, which are the really famous and useful packages and libraries for data visualization and data analytics available in the Python. So there are several bindings that we use in this workshop, such as the NumPy, Pandas, Matplotlib, and Seaborn, which are listed here. So in order to import or initialize them in the environment, you need to type these commands as import NumPy as MP, import Pandas as PD, import Matplotlib, PyPlot as PLT, and import Seaborn as CNS. So these are the commands that would initialize these modules or these packages for you. So let me show you if I go to my Google Colab account and create a new notebook here. In order to initialize the NumPy, you need to type the import NumPy as MP. For the Pandas, you need to type import Pandas as PD, import Matplotlib, PyPlot as PLT for the Matplotlib, and import Seaborn as CNS. And then just click here in this triangle here to run the cell, or use the Shift and Enter for running the cell and creating a new empty cell for you. So I'm just going to use the Shift and Enter. So it tries to connect to the Google Colab server, and then it would just run my commands, and hopefully if something is missing, it would download and install it automatically. So that's the advantage of the Google Colab environment, because if something is missing, it would just install it for you interactively and automatically. So that's the command. It just shows me that all the modules are loaded or imported successfully here. So as I said, you need to just type this command and make sure you don't see any error. But that's the warning. It's okay. It's just because of some mismatch between the pandas version available in the Google Colab environment, which is not really important for us. But beside that, you should not see any error here when you import all the modules. The next section is to how to upload dataset into NumPy array and pandas data frame. We want to use some of the files that we downloaded in the previous section, in the previous video, particularly the breast cancer dataset. So here we will learn how to upload a data file into the Google Colab environment from your local machine. If you come here, you just need to click here for the files. It just gives you all the files available in this machine in the Google Colab server. And in order to upload a file, you need to click here, upload to session storage. And then I'm looking for the breast cancer data.csv file in my local machine because I just downloaded that file. So if it's uploaded successfully, you should see the breast cancer data CSV in this tree of files and directories. As I said, you need to click on the upload to session storage and then see the breast cancer data.csv here. In order to load this file into a NumPy array, we use the gen from txt class or function here. So that's the full syntax for loading the file. I'm just copied here. So it says I want to store the data set in the breast cancer data.csv file. And I use the NumPy because I just have the NP here, which is the abbreviation for the NumPy as I defined in the first cell that I loaded the modules. And then I use the gen from txt function. The first argument here is the name of the file, breast cancer data.csv. The second argument is the delimiter, which because this file is a comma separated value file, so the delimiter is just a comma. And the skip header tells the gen from txt that skip the first line because the first line is just a header. And the NumPy arrays don't have any functionality to load the headers. So that's the reason why I want to skip the first line. If I click the Shift Enter again, it just loads the file into the data variable or data array. As I said, the first argument is the file name, the second one is the delimiter, and the final one is just tells the NumPy to skip the first line because it's just a header. It's not the actual data that we want to use for the visualization. One problem with using the NumPy arrays in comparison to the pandas data frame that we will use in the next section and the rest of this workshop is that if you have a mixed data type data set in your file, for example, you have some numeric values and you have some other string for some names or some string values. It's really hard to handle this kind of mixed data type in the NumPy array. And because of that, also you need to tell the NumPy to just skip how many lines, because those lines maybe are the headers. As a result, one of the best alternatives to the NumPy arrays are the pandas data frame that just could load the file automatically, find the data type automatically for you, and also find the headers automatically, and then you can just call the column of your table based on the name of the column that you just have in your header. So I'm going to load the same exact data set by using the pandas data frame as well. So that's the command. I just named my pandas data frame df, which is just the abbreviation for the data frame. You can just use whatever you want here. And the first one is the PD, which is the abbreviation for the pandas, as I defined the first cell here, import pandas as PD. And the read CSV file would read the CSV file, the breast cancer data.csv. And that's it. You don't need to tell what's the delimiter or how many lines you want to skip, because that's just about the header. So I'm going to load that as well. So make sure you don't see any error, because if you see some errors here, that means the file is not loaded successfully into the Python environment. So make sure you don't see any error when you run the cells. As you see, in comparison to the NumPy array, using the pandas data frame are much more easier and much more understandable in comparison to the NumPy arrays. So, as we said, we loaded these two data sets. Now we want to use, for example, the first and second column for creating a scatter plot. The syntax is that because every file that is loaded from the file by using the gen from txt is just sorted based on the rows, but because we want to use the columns as the x and y for the visualization, we need to take the transpose, which is just this t would transpose the data variable as is defined here, and I take the first column, that is 0, as the x variable, and the second column shows as the 1 as the y variable. So make sure we have them here. As I said, we need to transpose that because it just is stored as the row, but we want to use them based on the column. So these are two commands define our x and y for the visualization. Make sure you run the shift enter to define the x and y variables, and then use this plot function from the matplotlib to plot the x versus y. And this O denotion is just shows we want to use the circles for the markers here. So I'm just going to type that here. I want to plot the x versus y, and the markers should be just a circle. So if I click here, and so that just plots these two data points versus each other. You see that we don't have any x-axis or y-axis labels, and also it's really hard to find what was these two variables that we plotted against each other. So in the next sections, we will see how to make the visualization more informative and much easier in comparison to what we saw in this introduction here. But in comparison to using the pandas data frame, it's more informative because instead of defining the x and y, I could use my pandas data frame defined as df, and I want to use the mean area as the x because I know that the mean radius is the first column in my data set, and the second one is the mean texture. You see that it just gives you some even suggestions what variables available in your pandas data frame, so that's really useful. And then again, I want to tell that I want to use the circles for the marker. So I should see the same visualization, but you see that using the pandas data frame is much more informative because instead of using the x, y, or 0, 1, I could just call the columns based on their names that I have in my header as the mean radius, mean texture, or any other columns that you have in your data set. So that's the power of the pandas data frame in comparison to NumPy arrays. So that's much more informative and close or similar to the English language. So at the end, you could see the final notebook for the visualization that we have in this section, in this shared Google Colab notebook. So make sure you go through all the materials in this section. And in the next videos, we will learn how to use Seaborn and other functionalities of the Python bindings for creating more informative and compelling visualization. Thank you so much. Hi everyone. In this third section of the Introduction to Data Visualization by using Python, we will learn how to create the bar charts and box plots by using the pandas data frame and using the matplotlib. So if you click on the next page, this section we want to create the bar charts for the first section of this video. We will use the COVID-19 dataset across the county level of the South Carolina, and then we'll use the pandas data frame and matplotlib for the visualization. So make sure you upload the data as CSV as I just see in the previous videos in the Google Colab environment. And we want to just sort this data set in the descending order based on the number of the cases in each counties, and then create a bar chart based on the number of the cases and the name of the counties that we have for the first top 10 counties with the highest number of the COVID-19 cases. So I'm just going through the notebook here. First, you need to load the necessary modules as NumPy, Pandas, and Matplotlib as you saw in the previous videos. And then load the data set for the COVID-19 of the South Carolina into the Pandas data frame by just using the read CSV function. Just gives the name of the file. Make sure you upload the data CSV here by using this upload to session storage. Then here we sort the values of the pandas data frame based on the number of the cases, because we just named the columns that represent the number of the COVID-19 cases as cases, and we want to have them in the descending order. So we tell the pandas to keep the ascending as false. As sort the values in the descending order. Then we create empty figures based on the size that we gave. Here I just gave the 15 by 5. That's just the size that you can just define based on your choice. My X variable is the name of the counties, and I want to choose just the top 10 counties with the highest COVID-19 cases. And the Y variable is the number of the cases in those 10 counties that we choose from the highest number of the cases in the counties of the South Carolina. Then here, that's just the main command. You see it's just a plt.bar. It just calls the function that just plots the bar chart for you. And here, for the position of the bars, we need to define values from 0 to 9, because we have 10 bars. We want to put them in the position of the 0 to 9. And we just call them in the X pose. And we have the values of the number of the cases as the Y variable. And the color, you can choose whatever you want based on the color that you want for the bars. Here we put the X label, called as the PLT X label, as the name of the county, and the Y label as the number of the cases. Here Y label shows the number of cases, and the title just depends on you and up to you to choose whatever you want. But because it would be more informative if we tell what's this bar chart about, so we tell that it's the COVID-19 cases in the South Carolina counties. And at the end, we match the position of the bars we define from the 0 to 9 to name or the string of the counties that is stored in the X value. And then finally, we plot them and make sure that everything is placed in the correct position by using this tight layout. We just make sure all the X and Y labels are placed correctly. So at the end, you should see this bar chart here that just shows the sorted values of the number of the cases in each county. It just shows that the Richland has the highest number of the cases at that time for the April 20 day, extracted from the New York Times data set. And it just goes smaller and smaller because we just sorted them in the descending order. So that's the final visualization for using the COVID-19 data set for the bar charts. Sometimes for comparison of some two groups in your data set, it's useful to have them uh, or visualize them based on the box plots. Box plots are mainly useful to see if there is any meaningful statistical difference between two groups based on a variable. For example, let's say in the breast cancer data set, you have two groups of benign and malignant cells or cancerous cells, and you want to know if, for example, the mean area in these two groups is higher in the benign or malignant cells. So you can just compare these two groups based on the box plots. In the next section, we just load the breast cancer data.csv as we saw in the previous notebook into a data frame that you can just choose whatever name for this DF2. Instead of that, you can just choose whatever name you want. Make sure you have the breast cancer data.csv uploaded here. Then I'm just detaching the benign and malignant group by just telling the data frame to find the location of all the data if the class is equal to the benign. So I'm just calling that data frame benign, and then having the same thing for the malignant cells, selecting all the rows of the data frame based on the condition if the class is equal to the malignant. So you just select all the rows that the class is equal to the malignant. So we just detach these two classes from each other, and then we create the unified data structure called the data by combining the benign and malignant based on the mean area variable. You can just choose whatever column name that we have in this data set for comparing these two groups together. And then we just plot them based on that. We just give the data, and also we want to show the outliers. So we have the outliers by showing the diamond for the markers, and we want to show the median of the bar chart by just enabling the notch to true. So finally you should see the final visualization of this box plot here that just shows the uh, mean area. We want to have them as the mean area. So I'm just going through this. So we see that the mean area is relatively higher in the benign cells in comparison to the cancerous or malignant cells. So that's useful for comparison of these two groups together. And these green diamonds that we define just shows the outliers that we have. So these are the outliers in our data set. And this box plot tells us that the mean area is relatively higher in the benign group in comparison to the malignant one. So that's the purpose of uh, box plots, that just useful for comparison of two different groups together. So as I said, you need to load the modules. I'm going to go briefly over the steps that we saw in the notebook. Load the modules, load the file, sort them in the descending order, create the visualization here by showing the bar chart for the number of the cases based on different counties that we have in the South Carolina. That's the final visualization. And again, load the data for the breast cancer data. Detach them or select the benign and malignant cases from the initial data frame that we have. Define the markers for the outliers and then plot the box plots that you see here. So it just shows the mean area is higher in the benign group in comparison to the malignant one. So the final notebook is shared here that you can access and see all the visualization and go through the materials yourself. Thank you so much. That's the fourth part of the introduction to data visualization by using the Python videos or for this workshop. In the previous video that we saw that how to use the pandas and matplotlib for creating the bar charts and box plots. In this section, we will see how to use the Seaborn and the pandas data frame, which makes the visualization much more compact, more easier, and understandable in comparison to the traditional way of visualization by using the matplotlib. If you click on the next page, you want to use the Seaborn in this section combined with the pandas. And in comparison to the previous section that we used the COVID-19 dataset in the state of South Carolina and the breast cancer dataset, you want to use some of the generic available dataset in the Seaborn. The first one is just the Titanic, which just shows the number of the survivors or number of deaths in the Titanic ship. So we want to create some similar bar charts that we have for the COVID-19 data set based on this generic data set available. So you don't need to load any file for this notebook here in this section. First, we'll just load that generic data set called the Titanic, but you can just use whatever data that you have in your file or even use the previous Panda breast cancer or COVID-19 data sets for the visualization. Then we want to use the categorized plot shown as the cat plot here that just shows, because the Seaborn create the bar charts based on the categories or different class that we have in the data set. So the x-axis is just the sex or the gender of the passengers as male or female. And the y-axis is the number of the survivors or just the percentage of the survivors. And the class just shows the class that passengers bought the ticket for the Titanic. First class, second, third, or fourth, the third class. And the kind of the chart that we want to create is just a bar chart. And finally, what's the data that we want to use for this visualization is the Titanic that we loaded here. So that's it. You don't need to define any figure or call the matplotlib for the visualization. If I come here, first you need to load all the modules as we saw in the previous sections. It just tries to connect to the Google Colab servers and then initialize the modules that we want to use for the visualization here. So we need to wait after that. So it seems just working now. And then define some style for the Seaborn. And then load the Titanic as we saw, Titanic dataset. And then create this bar chart here that just shows the percentage of the survivors in two different sex categories and also based on different class of the tickets of the passengers for the first, second, or third class that they had. And the kind is just a bar chart, and the data is just, of course, you want to use the Titanic. So it just creates this bar chart more easily, more understandable in comparison to what we saw for the Matplotlib. And in the second part, we could just create box plots or even other kinds of the categorized plots based on the fare that the passengers paid for their ticket, the percentage if they survived or if they did not survive. And then we want to categorize this bar chart into 3 different bar charts based on the class. And in comparison to the previous one, we saw that it's just a bar chart. We want to define the kind as the box plot and then orient them in the horizontal orientation, and it just defines the aspect ratio and height, which doesn't really matter. You can just choose whatever value do you want for the height of the plot or its aspect ratio. And we want to make sure that all the fares are greater than 0. So make sure we just create a condition as the fare is greater than 0, and then have the excess scale as the log. So we would have the excess scale in the logarithmic scale, and then have this box plot here as well. You see that it's more understandable and easier to follow in comparison to what we saw for the Matplotlib. So Seaborn is a really powerful library that could be used for all kinds of visualization and data analytics. We saw all the visualization in this section, and the other one is just a different type of box plot. For this one, again, we use another generic data set available in the Seaborn to show how different functionality just work, but you can just replace this data set with your own data set, or even use the breast cancer or COVID-19 data sets for the visualization. So I'm going to the top. First, we load the TIPS data set into the TIPS data frame that we just choose for its name. And then again, the cat plots could be used for creating the box plots. We want to use this box plot for different days of the week, and then show the amount of tip that the waiter or waitress received, and categorize based on the sex or gender of the customers. And the kind of this box plot is called the violin because it just looks like the violin, but it's more useful even to see the shape of the distribution, because this violin shows you at which points you have more concentration of the, for example, the tips that you have. For example, for the Sunday, it just shows the amount of tip is concentrated around $4 here, because that's just the higher distribution is for the female customers. But for the male customers, it's a little bit smaller, near the $3 for the tips at the Sunday. And we want to split them, of course, in different categories, and also the data that we use is called the tips. So that's much more easier for creating the box plot in comparison to the Matplotlib that we saw in the previous section. That's the final visualization of this box plot, and you can just access the whole Google Colab notebook here in this link. So make sure you go through all the materials and see how you can just use even your data set or even the previous files that we have for the breast cancer or COVID-19 data set. Thank you so much. In the previous video, we saw that how to create bar charts and box plots by using the Seaborn and Pandas data frame. And we saw that it's much more easier to create visualization based on Seaborn because it's more easier to define the variables and it's closer to the English language. In this section, we will learn how to create a scatter plots and line plots by using the Seaborn and Pandas data frame. So make sure you click on the next page. As I said, we want to create the scatter plots and line charts based on the pandas data frames and seaborn. Still, we use the same tips data sets that we used for creating the box plots. In order to create the scatter plot, we use, instead of the cat plot, which was for the categorized plots, we use the real plot, which for the relation or relative plots that just relates two variables together. And we could define some hue for classes. Here, as you saw, that the main command that we use for uh, the scatter plot is the SNS rel plot from the seaborn. Rel plot is for the relative or relation plots. The x-axis is the total bill, and the y-axis is the amount of tip received from the customers. And we want to categorize these data points based on if the customer was a smoker or not. And also the style of the points in the scatter plot, for example, the circle or triangle or X uh, is the time that the customer was present in the restaurant, for example, dinner or lunch. As you saw, that's the final visualization that just shows us relatively for both cases of a smoker and non-smokers, the amount of tip is increased by amount of bill, which makes sense because the higher amount of bill probably would result to higher amount of tip. And there is no really significant difference between the lunch time and dinner time based on the amount of tip. So that's the visualization based on the scatter plot. And also the line charts are useful when you want to show the continuity of the data. For example, let's say you have some continuous data set based on time frames in the fMRI. You want to show the signals captured along a time snapshot. Here we loaded the fMRI dataset, generic dataset from the seaborn, but you can just replace it with any other custom dataset for your own, or even use the breast cancer or COVID-19 datasets. And again, we use the rel plot for creating the line charts. The x-axis is the time point, which shows the time interval of the signal that we captured in the fMRI, and the y-axis shows the signal strength. So, but the kind here, instead of showing the scatter plot, we want to show a continuous line. So the kind is defined as a line. And of course, we use the data of the fMRI that we loaded here. So that's the final um, care for the line chart that we created. I just suggest to just replace the fMRI or the TIPS dataset for your own dataset and see how you could just create visualization based on your custom data. And I go briefly over the notebook which is available in this link. If you click on the final link here, you would find the notebook that recreates or reproduce all of these visualizations. Similar to the previous sections, we just load the modules, then we load the data set, then we plot the scatter plot for the bill versus tip, and finally we load the fMRI data set and we plot the line chart of the time points versus the signal strength, and we just define the kind of that it's as a line. So you see that the visualization by using the Python and seaborn and Pandas data frame is really easy, and it's closer to the English language. So you can just replace all of these data set for with your own data and see how you could create the visualizations. That's just good homework for you. Thank you so much. Sixth part of the uh, introduction to data visualization by using Python. In the previous video, we saw that how to create the scatter plot and line charts based on the seaborn and pandas data frame. In this section, we briefly go over creating 2D plots based on a multidimensional data set of the breast cancer data set that we have. If you click on next, 2D heat maps are ideal for visualization of the multidimensional data sets. In this section, we use the breast cancer dataset. Make sure you just upload the breast cancer data.csv into your notebooks. And then we want to create a density of 2D plots based on the benign and malignant cells based on the mean area and mean texture. Similar to the previous section that we created a scatter plot, we want to detach the benign and malignant cases here. We just create a subset of the data set for the benign and malignant. And then we create a subplot based on a different figure size that we defined here. We set the aspect ratio as the equal for the x and y axis. And then KDE plot just plots actually converts the scatter plot into a 2D heat map. So the first argument is the mean radius of the benign cells, and the second argument is the mean texture of the benign cells. And then you say all of the points or all of the pixels in this heat map should be blue. And for the other one, for the malignant cases, we have the same mean radius and mean texture, but we want to show them as a red. So you should see at the final, you should see two regions of the blue and red that just show you the concentration of the benign and malignant cases based on different mean radius and mean textures. So that's the final visualization that shows relatively the malignant cases are concentrated at the low mean radius and relatively low mean textures, but the benign cases are concentrated in the higher mean radius and higher mean textures. You see the boundary difference between these two regions. So that's the 2D plot that we created based on a multidimensional data set. You can just replace this mean radius, mean texture with any other column that we have in this breast cancer data set. I just suggest to try different data set or different column names to see how this density or 2D heat map would be changed. The final notebook to reproduce these visualizations are located here. Briefly, I would say you just need to load the data set plus the modules, and then create the style of the seaborn, detach the benign and malignant cases by using the query if the class is equal to the benign or if the class is equal to the malignant, and then create an empty plot of the size 8 by 8. It's up to you. You can choose whatever you want for the size, and then plot the densities of the KDE plot of the benign and malignant cases. So that's the final visualization, and you can just replace this mean radius or mean texture with whatever variable that you want. So thank you so much. In this section, the final videos of the introduction to Python for the visualization and data analytics. We'll move on to see how we could create the animated visualization for the dynamics or time-dependent data sets. So make sure you click on the next page here. In order to show the time dependency or dynamics, we could just combine different frames and show the final visualization as an animated plot. First, similar to the previous section, you need to load the modules. In this section, we use a random generated data in comparison to the previous data set that we used, but you can just use whatever data set that you have or just replace it with the breast cancer data set or even your custom data set that you have. But here, for just showing the capability of the animated features of the Seaborn and Matplotlib, we use the random generated data. Then we get the data and store them in the x, y variables, and we create a grid based on the x and y. Then we define the x and y axis to just make them animated. And finally, this animate graph would replace different frames that we have. And finally, based on the Matplotlib animation, Fonk animation, we could just create the animation plot that we want to create based on the random data that we generated. But you could just replace that with any other data set. Here, it just shows the density or the KD plot that we had even for the breast cancer data set, and it also shows the distribution in the X and Y axis for different time frames. And you see that how different time frames are changed in this animation. So it's like you have different time frames for your data set, and you want to see based on the different or dynamic of your data how this density of the points would be changed in the 2D plots. So that's the example of how you could use the animation capabilities of the Matplotlib and Seaborn. At the end, you could find the final notebook to reproduce this visualization. If you come here, I briefly go over the steps. As I said, you need to load the modules, define the random data, and get the data and put them into the joint grid to create a 2D plot, define the X and Y axis, and then create the animation based on this plot for the KD plot, and define the frames, and also finally create the animation. So that's the final visualization that you could see, and you could just replace this random data with your own custom data set. That would be useful for exercising and using other data sets and see how you could create the visualization. So at the end, make sure you, if you go through all the materials in this workshop, make sure you send the visualization to my email address shown again here in our first page as the yousefi@clemson.edu. And thank you so much for your attention and watching our movies and your interest in data visualization. Thank you so much.